a problem. At a point in between Earth and Moon, capital R1 from the Earth and capital R2 from the Moon, small g equals 0. Mass of Earth is 81 times mass of the Moon. Find the ratio R1 by R2. So this is the G is the intensity of gravitational field, and intensity at a distance small r from the center of the field creating body is G equals Gm by r square. This is Earth, Moon, and at the position distant r1 from the center of Earth and distant r2 from center of Moon, G equals 0. What is the ratio R1 by R2? That is the question. Potential at G, intensity of gravitation at G 0 means intensity due to Earth is cancelled by intensity of the Moon, or the two intensities are equal and opposite. So you can equate the two intensities and get the results. G1, intensity due to Earth is ME. Here we have to find the ratio, so you can avoid capital G just to save time. So instead of writing Gm by R, you can write it as simply M by R. You can avoid G because we are going to take the ratio. So potential energy, intensity due to Earth at distance R1 from the center of Earth is, just to take it as ME by R1 square, equals intensity due to Moon, let you take it as M mass of Moon by R2 square. But ME is given to be 81 times mass of the Moon. So in the place of ME, write 81 M Moon by R1 square equals M Moon by R2 square. Therefore, R1 square by R2 square equals 81, or R1 by R2 equals 9. The ratio is 9:1, or R1 by R2 is 9. Thank you. Another problem. Assume the Earth to be a perfect sphere of radius capital R and of uniform density with a spin about the polar axis. Find the total mechanical energy of a body of mass m at one of the poles and at the equator. This is the question. This is the polar axis, and the Earth is spinning about this polar axis. So, angular velocity at the pole is 0 because the pole doesn't take part in rotation. Earth is rotating about the axis passing through the pole, so the polar region is not taking part in rotation. So omega, angular velocity at the pole, is 0. The maximum angular velocity is at the equator. When the body is placed at the pole, it has only potential energy because relative to the pole, polar axis, pole is at rest and the body won't have any kinetic energy. So total energy of the body placed at the pole will be its potential energy. Potential energy at the pole is total energy at the pole. At the pole, total energy equals potential energy equals minus gmm by polar radius of Earth, or simply R. It is said to be uniform sphere, so radius is same everywhere. So gmm minus gmm by R. But gm equals R square into G. So R square G into M by R. So total energy at the pole is minus mgr. When the same body is placed at the equator, total energy equals potential energy plus kinetic energy, because there is angular velocity at the equator because of the spin of the Earth. And there is a linear velocity associated with this spin. The total energy at the equator, E, total energy equals potential energy, that is minus mgr as before, plus half mv square, where v equals r omega. Omega is the angular velocity of the spin, which is 2 pi by t, period of the spin. That is nothing but 24 hours. So answer is total energy at the pole is minus mgr, and total energy at the equator is minus mgr plus half mv square. That's all.